Let's name each of these compounds. These are alkenes. They have double bonds. In order to name an alkene, you follow the same rules as an alkane or anything else that has a functional group. You decrease the number assigned to the functional group, and you number the longest carbon chain that contains that functional group. So we would name this with bute. Now, if this was an alkane, we would call it butane, but it's not. So we take away that A and we make it butene. We have to say where that double bond starts, and for this butene, it starts at carbon 1. This is also a butene. But this butene, the double bond starts at carbon 2, so we call this 2-butene. This compound, 1, 2, 3, 4, has 5 carbons, so we would call that pentene, and the double bond starts at carbon 2. But what if we number it the other way? If we number it the other way, the double bond starts at number 3, so we would number it from the left. This compound has the longest carbon chain, 6 carbons long, so this is hexene, and the double bond starts at carbon 3, so this is 3-hexene. This compound is cyclopentene. You do not need a number for cyclopentene. There are no other substituents or functional groups in this molecule. Therefore, the double bond would be defined as being between carbons 1 and 2. Now, this compound is a little more complex, so I would want to number it starting from the right in order to get my alkene to have the lowest number, and then my chlorine would be a number 4. So this way, the double bond is 1 and the chlorine is 4. If I was to number it from the other side, from the left, the chlorine would be on carbon 2 and the double bond would start at carbon 4. Because 1,4 is less than 2,4, we're going to go with the 1,4 method. What that means is the alkene starts at carbon 1 and the chloro is 4. So we would call this 4-chloro, and you could name it 1-pentene, or what is more common now is to put the 1 right before the en, so 1-ene. 4-chloropent-1-ene. Either way is okay with me. Now this one, again, we are a little complex. We need to number the longest carbon chain that contains our functional groups and substituents that we can name. So here we have 4 carbons, and it is a butene, and we have 2 methyl groups. Now I just want to show you, I'm going to change to a different color here, maybe black. If I was to number it this way, then my functional group would start at carbon 2, and my bromine would be at carbon 4. Now my initial way is starting at the carbon that contains the bromine. My double bond is still at carbon 2, but the bromine is then given a 1. And because that decreases the number of my substituents, I'm going to leave that as 1-bromo. Because I not only have 1-bromo, but I have 2,3-dimethyl. Remember, when you have more than one of the same substituent, you have to give them a numeric prefix. And it doesn't matter where those substituents are. They could be on the same carbon. Everybody gets a number. So this would be 1-bromo, 2,3-dimethyl, 2-butene. Like the previous example, this could be 1-bromo, 2,3-dimethyl, butene as well. For this one, longest carbon chain that contains the functional group, decreasing the numbers of the functional groups and substituents. So here we have a hex 3-ene. That's one way to write it. And then we have our 2 substituents here. So this is 3,4-dimethyl. Now we'll get into stereochemistry in the next module for Organic 1, where we can start to identify how things are arranged around that double bond. For the next compound, again, our longest carbon chain that contains our substituents and functional groups, decreasing in the numbers as possible. This is a hex 3-ene, and then we have our methyl group. So it would be 3-methyl hex 3-ene. You could also call this 3-methyl 3-hexene. Just to make sure if you have a double bond, you have an E-N-E and a number indicating where that double bond starts. So for this molecule, I'm going to start numbering on the right. So I have a hept 3-ene. Hept, H-E-P-T, is what we use for 7. Now I have a chloro on 3 and a methyl on 4. So this would be 3-chloro 4-methyl hept 3-ene. Again, as previous examples, you could also call it 3-chloro 4-methyl 3-heptene. For this compound, we have an alcohol and a bromine. So we would name this pentanol. We do not have a double bond. Put that 1 out here and a 4-bromo. Now, similar to the hexene, you could put that 1 on the inside of this name. Call it 4-bromo pentan1ol. Either way is fine with me. 1, 2, 3. We could number this way, or we could number this way. Now, this is a case where we have 2 functional groups. Well, in the lesson, I have written out this table, and this table is common. You'll probably find it if you want to do a search online. You'll probably find it prettier than how I have it written out, but it's the same hierarchy. And the hierarchy is generally the more oxidized the functional group, the higher in the table it will be. So what we have is an alkene, which is down here, and I can never tell if you can see my cursor, so here's hoping. We have an alkene down here, and then we have an alcohol that's above it. Because the alcohol is above it, it gets the priority with the numbering and with the name. That means we're going to number from the right. So this would be a 1-prop 2-ene. Well, if I'm going to put the number on the inside, let's do it this way. Prop 2-ene 1-ol. If you're going to put it on the inside, put them both on the inside. Otherwise, you would have to name this with the alkene prefix, which is given here, alkenol. So this would be 2-alkenol 1-propenol. So you see this ends up being, although it's a complex name, this ends up being a little more clear. For the next compound, again, we have an alcohol and an alkene. So the alcohol has priority in numbering and in with the ending. So this would be pent 4-ene 2-ol. This one as well. 5, 6. So we would have a hex 4-ene 2-ol, but what about that bromine? Well, that bromine is at carbon 5 now. So that's 5-bromo hex 4-ene 2-ol. This wedge and dash identifiers here, we're going to keep those for stereochemistry. That's the next module in Organic 1. So I'm going to move on to this amine alcohol here. So here we have an alkene, an alcohol, and an amine. So let's go back. We have, we come to alcohol first. So alcohol has the hierarchy. That means it needs to have the lowest number and it gets to be the ending of the name. So we're going to use amino for our prefix. So I'm going to number the other way in order to give the alcohol the lowest number possible. So this would be hex 5-ene 2-ol, but I would have this amino group. So this would be 4-amino hex 5-ene 2-ol. Again, we're going to leave these wedged ones for the next module.